Hi, everyone. Welcome to today's session on OpenSearch Query Insights. My name is Chenyang, and this is David. We are mainly working on search resiliency, performance, and observability in OpenSearch. And we are also the maintainers of Query Insights and the corresponding dashboards plugin. Today, we want to give you a high-level overview of Query Insights. We want to cover what we are really trying to do here and why it is important. I also want to cover the use cases and the features we have been developing since last year, and the future work we are planning. From this session, I hope you can know, as OpenSearch users and search engineers, how Query Insights can be beneficial for you. So let's start with what Query Insights is and why we are building it. Search is the core use case for OpenSearch, right? And naturally, we all want our search queries to be fast and efficient. But here's the thing, and this is actually what we keep hearing from admin users and search engineers. They are really trying and struggling to understand what's happening with their search performance. Let me paint you a picture of what they are dealing with. Imagine you are an admin user, and suddenly your cluster is slow. What do you do? Well, right now you're kind of flying blind. You can rely on the slow log, but you cannot easily answer basic questions like which queries are eating up all the resources in the past hour, who's actually sending these slow queries. And when we say a query is slow, where exactly is it slow? Is it the query phase, the fetch phase, or something else? These are not just nice to have insights. These are very critical questions that admin users need answers every single day. So yeah, that's the core problem we are solving with Query Insights. We are building a comprehensive framework to capture detailed metrics at every stage of query execution. And then we asynchronously process these metrics and group similar metrics together to identify patterns, and then surface these patterns and metrics through APIs and dashboards. The ultimate goal here is to transform how people manage search performance in OpenSearch. Instead of scrambling to fix problems after issues happen or user complaints, you'll be able to spot issues before they even become problems. Which queries to optimize, which users to talk to, and where to focus your optimization efforts. We have been shipping this incrementally since OpenSearch 2.12, and I want to show you what we have built so far. As I mentioned before, Query Insights is composed of a backend and a frontend plugin. Once you install both, you can use it with APIs or on dashboards. Here's a list of the features we have released. Let me walk you through the configuration page on the dashboard first. On this page, you can control exactly what Query Insights tracks for you. First, you can choose your metric. Are you interested in latency, CPU usage, or memory consumption? Each tells you a different story about your queries. Then there's window size. This is your rolling time window. If you set it to 5 minutes, you're tracking your top queries for every 5 minutes. If you set it to 1 hour, you get the broader view, right? And then it's the token size. This determines how Query Insights, how many queries to keep for each time window. If you set it to 10, Query Insights keeps track of your 10 worst queries or shapes for the last window. And one really cool thing we added is query grouping, because sometimes the same back query gets executed for many times, and suddenly the same query occupies the entire token queries overview page. With grouping enabled, we'll be able to treat these queries as similar or same patterns as groups. So we group them together so that you can easily see these patterns of these problematic queries instead of all the single queries. I'll explain more about this in the next few slides. We'll also allow users to export Query Insights or top queries data to sinks so that you can configure, for example, you can configure the type of exporter and also the retention policy. David will cover more about this later as well. All right, so once you configure everything, you can navigate to the overview page. At a glance, you can see like your most expensive queries, whether that's by latency, CPU, or memory, right? On each row, you can see there's CPU time, memory usage, latency, the index, and also total shards, the coordinator node involved. And yes, you can filter and sort by any of these metrics. So say if you suddenly have a CPU spike, you can simply sort by CPU and see which queries are the culprits. Now, when you click on one specific query, you can get the full story. We break down the latency by phases. So as you can see in this case, yeah, this query is spending a long time in the query phase, but relatively short time in fetch. This actually tells you where to focus your optimization efforts on. Now let's look at the grouping, one of the interesting features we have. If you enable grouping on the overview page instead of individual queries, now each row represents a group of similar queries. The number you are seeing, the latency, CPU, and memory usage, these are like the averages across the entire group. So yeah, on the detail page, it displays all the averages as well. Plus, we give you a representative example of this group so that you can understand better on what these queries are actually doing. And here's something we introduced in 3.1, the live queries page. And I think Andrew also covered this in his slides as well. So these are the queries currently running on your cluster. So if someone says, oh, or like my OpenSearch cluster is slow right now, you can see the long-running queries by node, indexes, detail of these queries, and also cancel them if needed. The beauty of all these is it comes out of the box in OpenSearch distributions. You can just install the plugin, configure what you want to track, and you got visibility. Now let me hand over to David to talk more about the APIs that supports these features under the hood.
Okay. Hi, everyone. Query Insights has 3 APIs. First is the top queries. Second is live queries. These 2 APIs supply the data that you saw in the dashboards. There are additional query parameters for these APIs, but this is the bare API path. And the third API is health stats. This API provides valuable debugging information to on the Query Insights plugin. However, we don't show this data in the dashboard because it's mainly used for debugging purposes. As for settings, all Query Insights settings are dynamic cluster settings. This is an example REST request for updating the latency window size. However, if you have access to the Query Insights dashboards, it's much easier to update settings via there. Next, I'll go over the architecture of the top-end queries feature. Remember this feature, the goal of it is to track and record the most longest running queries in terms of latency and the most resource intensive in terms of CPU and memory. So when search requests complete on the domain, they're first inserted into this Query Insights request buffer. Entries in this request buffer include the original search query, plus their total latency, CPU, and memory usage, plus the other attributes you saw in the dashboards table, such as like search type, coordinator node, those things. Every 5 seconds, the request buffer drains into the 3 priority queues. There's 1 priority queue for each latency, CPU, and memory. If a request exceeds the minimum latency, CPU, or memory currently in the priority queue, then it gets inserted into the priority queue. Otherwise, that request is ignored. And so these priority queues are of size n based on the cluster setting that you have configured on your domain. By default, n is equal to 10, and you can have a different n for each metric type. After the current time window expires, by default, that's 5 minutes. All the data in the priority queues is exported to your configured sink. Also, the priority queues are wiped clean, and then the process restarts for the next time window. This architecture using the requests buffer allows us to process requests asynchronously so that the query insights processing does not affect your bottom line latency. Exporting top query data. Query Insights offers 3 export options: none, debug, and local index. Debug writes the data to a log, and local index writes the data to indices on your domain. And so local index is the default exporter out of the box. This saves the top query data into indices with the naming pattern on the screen, top_queries dash year, month, day dash hashcode, where hashcode is a 5-digit number. And this allows you to query top query data from the past. So you can retain this information and look at it days or weeks later. We have a delete after setting for the exporter. This applies to the local index. It says how many days of data you want to retain. And the default is 7 days, but you can configure it up to 180 days. Also, Query Insights manages the creation, deletion, and index patterns and everything of these local indices for you. So now I'll talk about some future work. We have a lot of things on the Query Insights roadmap, but these are 4 that I wanted to point out. First is live queries shard tasks. Right now, the live queries dashboard only shows request level data. So we want to expand this to include shard level data so that you can get even more granular insight into long running queries on your domain. Second thing is additional exporters for top end queries. Right now we offer the 3 exporter options, but users have expressed interest in other exporters such as S3 and Prometheus. Third item is integration with workload management. Workload management is a resiliency feature in OpenSearch that allows you to impose resource limits on certain groups of queries. So when workload management is enabled, every request will get assigned a workload group. And so we want to add this workload group as an attribute inside of Query Insights records and also display it in the dashboard so that you know what group long-running queries or high resource usage queries are associated with. And the last item is the Profile API Visualizer. The Profile API is a debugging tool in OpenSearch that's used to help identify where slow queries are spending their time. The output of this API is very verbose. It's a very long JSON object. So adding a visualizer in the Query Insights dashboard would be a very valuable feature to understanding this output. So these are our repository links. Feel free to look at any issues that are open. If you see any bugs or feature requests, you can open GitHub issues in these repositories. And everything we've covered today is covered in the OpenSearch documentation. So you can learn more there. Thank you for your time.
Does anyone have any questions? And also, by the way, if you want to contribute, feel free to take any. Yeah, go ahead.
Do you have any plan to install OpenSearch benchmark?
OpenSearch benchmark? So you mean combine the benchmark results in Query Insights, something like that? Yeah, that's actually a very interesting thought. We haven't thought about that because Query Insights is mostly on the currently on running queries or historical in the last few hours or something. Actually, if you use benchmark, OpenSearch benchmark to test against the OpenSearch cluster and you have Query Insights installed, you will get all these results. But we don't have specific or dedicated screen or support for benchmark. It will be similar to what like other queries, yeah. Yeah, go ahead.
I have a question. I want to enable all of my cluster this feature because some of users just sometimes suddenly ask me my cluster is getting slow.
Yeah.
And I have to analyze their cluster. But
Yeah.
I'm worried about if I turn on these features, it seems to require some additional resources.
Yes.
Yeah, so do you have any tip in case?
Yeah, sure. So I saw on your slides like you have thousands, 1,000 OpenSearch cluster, 1,200 or something. It's a lot of clusters, and depending on like the workload, let me see. Yeah, here's the configuration page. I think you can start with one metric, for example, tracked by latency, right? And you can set the n, a small number of n, for example, 10 or 5 to start with, and experiment a little bit. And the window size, depending on your use case, I would recommend 1 hour so that you can get the top 10 queries for every hour. That should be a good starting point. Yeah. Thank you. All right. Thank you.